All right.
Awesome.
Yeah, so evals. Like I think evals feel like this magic button. I think everyone feels like, hey, my AI pipelines don't work, but if I somehow solve evals, they will start to work.
Well, and I'll say some people haven't even gotten there yet. And like I think there's this like especially when you're new to building AI pipelines or you're new to a certain technique or model, which is pretty much everyone all the time. Like no one is an expert on every model and there's new stuff shipping every week, every month. And I think it can be paralyzing and it can kind of like kneecap the productivity of your team when everybody is trying different things in different ways. And without a way to understand, hey, this approach works better than that approach, without a way to evaluate the performance of whatever like problem your new approach on the problem you're trying to solve, it's kind of becomes impossible to make progress. And like Bob said, like it becomes this magic bullet where it's like, okay, if we just had a number from 0 to 100 that said, here's how good we are in this approach versus this approach versus this approach. Hey, we changed this thing and we got better here, but we got worse here. Um, it kind of can be very grounding and helps you bring a lot more, I think, engineering back into your process. Does that sound right?
I think so. But I think that's the feeling at least. And the thing that I have mostly captured. So I think the first time I really started thinking about machine learning evals came from when I was working on HoloLens. And that was the first time where I had a completely stochastic system where you really can't, there's no ground truth because capturing ground. So, for context for everyone else that doesn't know, HoloLens is an AR headset. And part of the AR headset job is to build a 3D representation of the world that it sees through the cameras it has. And in order to do that perfectly, the only way you can build evals is to build a simulation that perfectly simulates the camera hardware, which you cannot do. Like you cannot actually mimic how light is captured by the camera sensors perfectly. So the next best thing we can do is capture something that is pretty close to correct. And for that, you're going to use another sensor, and that sensor itself will have some errors. So we built this pipeline out that had some ground truth, and we tried to use that ground truth and tried to align it. But then we ran into problems like windows and mirrors, which basically don't get captured by any sensor very well. And then we had to like those existed in our data set. Like I'm in this conference room right now, I'm surrounded by windows. That's a real data set. And we wanted the HoloLens to work in there. So we had to approximate what it meant to have some sort of a score. And like let's say the HoloLens misses 1 square meter of an area in capturing a wall. Is that good? Is that bad? Like how do you evaluate is 1 square meter versus 1.2 square meters any worse or better? And
So
that's
it almost becomes like a question of like where do we spend our time and like what matters to the actual kind of end output of how good is our system as seen from like what outcome is it trying to drive?
exactly. So that's one part of it. And the other part is, can you even measure correctness? Like, how do you know if the 1 square meter you missed was actually a real hole or a hole that the other sensor also missed? Like, is it a hallucinate? Funny enough, we used to call them hallucinations as well. They're like hallucinated fragments. And like, how bad are hallucinated 3D assets that the HoloLens picked up that didn't exist in the real world? And measuring that was incredibly hard. We actually had a full-time person. We actually had like 1.5 full-time people whose full-time job it was for over 2 years to at best approximate some sort of metric. And we had no real metric in the end. It was just a pseudo approximation of the real system. And we did this for all sorts of things. We did this for hand tracking when we built hand tracking. We did this for eye tracking when we did eye tracking. And that's when I first realized is like there is no eval truth. There is no golden data set ever for most real problems. That's funny, Adisha. Yeah, and then it really comes to a matter of how do you balance engineering time that you have to do to build a system that can at best approximate the actual thing, the proxy for what you're trying to build for. Does that align with what you've seen too as Dex in the now the LLM world?
Yeah, and I see it as kind of like a gradual process too. Like I know we're gonna start like we're gonna get into this, but like every project starts with nothing. Like if there was already an eval, a really good eval for the problem you're solving, then it's almost certain that someone else is already kind of on the way to solving that problem. And the hard problems to be solved in AI tend to be the ones where no eval set exists or no eval set exists that is appropriate for the way that you're approaching it or the way you want to evaluate your solution. And so I think the tricky part is like a lot of teams get sucked into, cool, we're going to spend 6 months building our eval set and then we're just going to push it out and go. And I think what's a lot more interesting is this kind of more agile incremental engineering approach of how do we start with nothing? How do we make it pretty good to start? And how do we keep updating it and evolving the way we evaluate our software over time?
Yeah, exactly. And Dex and I put together some topics that we want to talk about today. Dex, do you want to copy and paste them into the chat really fast?
Um, I will do you one better. I will push up the README, which has the topics in it,
Even better. Okay. And while you're at it, do you want to
and
screen?
I'll link that.
You just want to screen share really fast then in that case?
Sure.
Cool. So
Um,
when we first think about evals, I think it's more of a journey rather than an answer right now. And any company that starts off saying that we're going to build evals automatically and it's just going to solve everything is going to be stuck because you could spend your entire company's lifetime building evals. Um, So I think what we want to talk about is how do we go from no evals to some evals to really good evals in an incremental way for any problem that you have today, rather than just like what exactly is a great eval. And by the way, we're recording all of these, so we'll post it on YouTube soon, and you'll have access to all of them. So,
yeah, sorry. Give me just 1 second here.
yeah. And today's conversation is going to be really, really interactive. So if people have problems that they specifically want to pose that we should talk about, definitely feel free to just like chime in and ask. You can post it in the chat, and we're happy to discuss those as well. The number one sneak peek that I'll give everyone before we get too into it is please stop using numbers to evaluate your systems. Do not ask an LLM on a scale of 1 to 10, how good is the answer? Stop asking it confidence scores. Um, because and I'll give you intuition how to think about this problem and why that matters. How many of you actually like ask confidence scores, just like humans, Mike? How many of you use confidence scores today? Can you like type in the chat or really quickly? Okay. Come on, all of you, please shame yourselves. I allow you to shame yourselves. It's okay. We're an open place right
You
now.
should have you should have asked them first and then told them that it was bad.
No, no, I think it's part of it. You gotta acknowledge which 5 steps of grief. You just gotta acknowledge it first, and once we've accepted it, um, then we can talk about it.
Okay.
Okay, cool.
Okay, cool. I'm just gonna merge this in right now. There's some
Okay,
work in progress code. Some of this may change throughout the episode, folks, but
cool.
let's pull up the evals workshop. Okay, cool. So yeah, here's what we want to talk about today.
So
Not how much you care
the
about
main
the
topics are really going to go about why evals are really good and what you can do if you have an answer key. And I think that's hopefully should be pretty obvious to everyone. But like,
I think
okay, Dex, sorry, I'm gonna make you co-host.
Sorry, yeah, I'll get on muting folks too.
Okay, there you go. You're made a co-host. And like why what we can do if we actually have an answer key. And that should be really obvious, but the most important thing, remember, we talk about this all the time on these episodes. The number one thing you need to build a really good AI pipeline is a really fast iteration loop. Evals are your way to iterate fast. Not initially, but eventually. If you have a team of 40 people contributing to your code base, you need evals just like you need unit tests, because that's what prevents CI/CD from breaking. And you need to do that because
Well,
not because developers are bad, but because we're all lazy and we all do push code sometimes, and CI/CD does a really good job of checking for mistakes.
right. So that's that workflow of like make a change, run the eval, see if it's better or worse, and then like don't push code that makes the eval worse.
Yeah. And like, how do you measure if it's worse or not is a totally separate question. But in proxy, that's really what we want to go do. And you want an easy way to go do that. Visualizing
Yeah.
eval results, we'll talk about that in a second as well. I'm going to flag that's a good question. Can you add that in your local notes deck?
Yeah.
Okay.
Yep. Yeah, I was about to do that. I love that.
Okay. Oh, you're screen sharing. Okay, let me screen share my tab because then we can. Um, the next question I want to talk about is how do you actually build an answer key? Because at least for me, most things I work on have no answer key on the very beginning. And those are also the most interesting things that we could have. So we'll talk about how to build an answer key from nothing. Hint, the answer is, you know how there's vibe coding? You should be vibe evaling in the beginning. And vibe coding
Whoa.
sucks, but you should be vibe evaling in the beginning. If you haven't used a lot of LLMs, you should 100% be vibe evaling. And we'll talk about why in a second as well. The the other thing the other thing that I think is really worth noting is a lot of people look at evals as holistic. But structured data versus unstructured data is a huge difference in the way that we do evals. And I think like Dex and I have talked about this a lot. So like Dex, do you want to share some thoughts?
Yeah, so I mean, like you have all these different. So I feel like where we got off the track a little bit, like as an industry with evals, was doing all this work to understand unstructured data and how good it was, because then you get all these things like sentiment categories and is the model outputting text that's rude. Like you have all these like kind of like baked in evals that are becoming a little bit like industry standard as far as like, okay, the first thing you can do is just pull this thing off and make sure your model is not recommending that people go, do something dangerous. I won't go into details, but things like that. And so that's like, and so it's like, okay, we need evals in the sense of like, we need one LLM to read all this unstructured data and then decide whether it's yes or no on a bunch of these like binary classifiers or like multiple category classifiers. Versus like a problem that I work with a lot is like extracting structured data from images and being able to say like, hey, here's 100 pictures of a passport. Like, can we reliably pull the data out of that passport? And for that, our answer key is very structured. It's literally a list of JSON fields versus like, can we get a 1 to 100 score? Either, hey, we have 100 outputs from the model, which of how what percentage of them like pass all our style guidelines as far as how we want our chatbot to behave or something. Is that a little
Yeah,
rambly, but does that make sense?
that nails it, Dex. And then really it's like this, and then there's a blend of the two as well, where I have some structured data and I can eval that with like programmatically. And some of it has to be eval with an LLM because I'm getting a summary. But even summaries, people are like, oh, I can only know if it's a good summary or not if I use an LLM. But that's not actually true. Let's look at the idea of like summarizing something. I can know how many sentences things have. I can know what the word count of the summary is. I can know how long it is. And then I can even know something like, does it mention specific keywords that it really should mention in the summary? Like if I ask for a summary about if I ask for, let's say, a summary about like a Wikipedia article, it should probably mention some of the key figures in the Wikipedia article up front. And I should probably know what those key figures are ahead of time. And some of
Yeah, I
the
feel like we need to hit the whiteboard.
let's do
People
that.
are Prashant is asking what's an answer key.
Yes.
And I think let's define some of this stuff. I will drop you the link real quick.
Thank you.
Or do you want to share and
Just send me the link in my DMs.
yeah. Um
So, and I think, sorry, to catch everyone else, an answer key is something like a rubric. Like in the case of like a classification problem, an answer key could be something as like, here's the correct classes for all these categories. In the case of like a resume problem, the answer key could be something more like, here's the fields that I want to extract. In the case of a chatbot, it could be the sentiment that a user should be feeling at any given point in the chatbot itself. It really depends on the kind of problem you have, but the idea is that your answer key is as close to an approximation about the correctness that you have. And like it could be sentiment and yeah, so I'll copy and paste a couple more things. It could be sentiment, it could be like intent capturing. So like did we capture the intent that the user asked us about correctly? And
okay, so
exactly.
that's something like someone comes in and says, I want to buy a new phone, and we want to validate that that becomes, browse products.
Exactly. Right. And it might even include browse products subcategory field, a subcategory phone as another thing.
Yeah.
Right. Like we might want all of that. And that might be like, we might want, and the accuracy of our system that we want might be, hey, you know what? For our system, we're pretty happy if it got to the browse products phone. We're very happy if it got to the products phone page. But it's like, oh, it's our choice about how strict we want to go make this. And I think the key part about having an answer key here is like if we go deeper into this like this I want to buy a phone thing that Dex wrote out, is like at this point many of us know that we're gonna have like a multi-step pipeline. We're gonna have like some sort of intent detection. After we have intent detection, yeah, after we have intent detection, we might route to like a different part, different things based on what the user is trying to do. And we can build evals for different parts of the system. So even though this whole thing is the chatbot, we could build eval just to say that, did we pick the right arrow down here? Is the intent selection good? Without even really arguing about like whether the sub box in here operated correctly. It doesn't have to be binary. That's the whole point that I was making. It's your choice. Obviously, if it's binary, it's going to be more easy to evaluate. But if it's not binary, and some problems just cannot be binary, like in the case of summarizing summarizing a Wikipedia article, it's virtually impossible to make that a binary classification. But what it can be is a great approximation for what we think is the truth. And I think that sounds a little vague, so I wanna talk about how to go do that really quickly. So, okay,
See what I'm doing here?
yeah,
This makes sense. Like this is like how you would basically write this in Python. And obviously you don't want to handwrite a unit test for all of these. This looks a lot like a table test basically, where you basically for a big set of inputs and outputs, you would just make assertions about them. And like you could do this in JSON or you could do it in CSV, but like you have your input and then you have your expected output.
exactly. And like this is not fun. This is not fun to go right. Yeah, and you can do this anywhere. Like the reason that like Dexter is probably saying that he's writing this in Python directly is because the more sophisticated your agent get, like as of today, like BAML doesn't allow you to compose functions. So you just can't write certain types of expectations really well.
Yeah.
But one of the most important things is this word that Dexter says, which is a table test. And Dexter said this because he's worked in these kinds of systems for a while now, but I want to articulate to everyone what that means. So when I'm doing a table test, and this is something to think about as you build more complicated evals, a table test for concept is to say that, hey, output has multiple fields in it. It has an input, it has an intent, and a subclass. Just because it doesn't match this perfectly doesn't mean it failed. I really want a table that says did output.intent match what I want, and did output.subclass match what I want. It's a table test, and I can run both of them in parallel without running only one. And that is incredibly useful when building LLM outputs. And I want to show a real, um, I'm
I'm
or
pseudocoding over
summarizer.
here.
Adish was talking about summarizer. So I want to share like a couple different examples of ideas here. So this is how we could build an intent classifier test case. And you could actually imagine even further, what if this was a chatbot, but I had like a probe, and we talked about probes a few times that I passed into my system that was able to introspect specific nodes in here. And then I could be like probe.intent and actually analyze the intent into my chatbot and actually know exactly what happened.
Oh, I see. So you're instrumenting through the steps, but you can also make assertions about the output, but it's actually like, you know that if what gets bubbled out of the probe is correct, then that's cor then the output you don't care like of the non-deterministic. If the output itself is like plain text, then it's really hard to evaluate if it's harder to evaluate if that's correct or not. But you can guarantee that the internals of the method actually were executed properly.
Exactly. Right. So like right over here, we talked about like this chatbot concept where the output is going to be a message that's shown to an end user. But we know our chatbot consists of many different substeps. So right over here, one of the substeps could be intent analysis. So we actually output out of our system the probe that tells us what the intent is and any other subcategories or steps that we find very useful. And then we would actually return that to us. Does that kind of make sense, Dexter?
It does. Are you drawing? I'm not seeing your stuff updating
No.
or
Letting you type.
okay.
Yeah.
Um,
Talk about a couple
cool.
more. So people seem to be really curious about how do you do things for summarizers, and then also how do we do things for a couple other scenarios. So while we do this, I'm going to send over a YouTube video to show, and I think this is probably the best example that I can have. Can I screen share, Dexter?
Yeah.
Okay. I'm going to
Yeah,
take.
you can steal it. Go for it.
Okay. 1 second. I'm going to do one more thing. Okay. So now let's talk about a couple more things that I want to talk about. People talk about summarization, so I'm going to get to that in a second. But I want to talk about like other kinds of things. So we've worked with a couple finance companies for quite some time now. And I think a lot of people don't realize how to think about evals for these kinds of systems. So I'm going to mute the video and I'll just talk through it. If my internet would catch up, I'm at 140p. I'm at 1080p. So
All right, here we go.
What the goal of this video is we're going to extract data out of financial records, all kinds of financial records. And normally I would run this code live, but it's just easier because I don't want to share. I don't have the actual PDFs on me right now. So it's just easier to go run this. And we all know how to go build this sort of thing. This basically becomes like a data model that has a class with all these fields attached to it. And then we also add a category near each one to know what category it is. So in this case, we have cash, mutual fund, and ETFs as a category, and we can see that the data pulls out. We all know LLMs can go do this. It's an extraction problem out of images. It's not too hard. We can go write this out. But now we get into the more interesting part, which is how could we build an eval system for this? Well, one way is one of us could actually handwrite the golden JSON for this automatically. And if you haven't done anything like this before, you should handwrite the golden data set for your JSON automatically. And the reason that you should do that is not because there's no easier way, but because the first time you handwrite a golden data set, you are actually going to find inconsistencies in your data model that make it look wrong. It's going to make you think about the problem in a way that very few things ever will.
And that's kind of key to all of this eval stuff is like define if you don't know what your inputs look like and what the structure of your outputs look like, it becomes really hard to build your test data set.
Exactly. Jonathan said it
So,
best. You need to build the intuition. And that's kind of the whole point about like when we were actually going to when we built BAML, the whole point of hitting play in the playground was to help you build that intuition. That's why I say vibe evals are the best. Because if you have no evals, the best thing you can do is look at the output. That is literally the best thing you can go do. And if the model outputs something reasonable, you know you're probably on the right track. But as you grow, you can't vibe eval because we're all busy people and we don't want to vibe forever. So we want to build something better. So we're going to build systematic ways to go do this. So for this, you can imagine building a golden data set of all of these exact financial transactions. And in my golden data set, I may be okay if asset name doesn't match perfectly. I'm okay with that. I want the symbol to be perfect. I want quantity to be perfect. I want current price to be perfect. And I want cost basis and market value to be perfect. So you can see how I can even have a blend of correctness on my golden data set, where I want a warning if the asset name doesn't fire, and I want to visualize that in some way, but I want everything else to be completely correct. And I think we could all go write that JSON. But now we can do something else, which is in this specific data model, we actually have some validations that are built into place. And we can do runtime evals. That means evals on production data naturally over time.
so what would one of those look like?
Does anyone have an idea? Actually, I'm going to pose this before I spoil it. Does anyone have an idea of, given this data model, what do they see as a possible runtime eval? You can unmute and talk, or you can just like type in chat.
I assume we're not including like the type of the dollar value should be a number and not a string, right? Like, let's go beyond that.
We get that. So Matt has a really good idea. Column sums, data from an API is another great one.
You could make sure that the cost basis times the price equals the market value, or I don't know. There's some like row-wise computation there that's supposed to add up, right? I don't do
Exactly.
finance.
And like this is exactly what the math is going to show. It's like quantity times current price should equal market value. We know that. That is a mathematical truth in our data model. And guess what? We can actually go build that out. Like we can actually just go do that. And that's a really, really fast operation that we can go do. It's pure programmatic, and we can just look at the delta.
Right. And Babel supports this, right? Are we going to go into that, or are we going to?
Yeah,
That's like that's like
separate problem.
runtime evals, right? That's
Yeah,
that's kind of
that's a separate thing. How you do it, like we can talk about in a second. Like, yes, you can do this in BAML, but that's not the point here. I think the point
yeah.
here is to like, look at your data model and think about what you can go do with your data models to see if you have some constraints you can build in. And this isn't just a one-way thing you can build in. You can actually build in multiple sums given this data model. I could say that, hey, all my cash value should equal this cash value. All my mutual fund value should equal this mutual fund value. So I can even have summings built in, not just multiplications per row, but a sum across columns as well, which can help me build even more assurance that the data is correct. And I'll give you an example about what happens when this data goes wrong. So we have another document here. I hope you can see. And I'm going to fast forward to the point where it's like done processing.
And while you're doing that, just like very clearly, this is interesting because it draws a line between. I mean, we looked a little bit at some of the testing stuff, but basically, these are all deterministic evals. This is not a model outputting whether something is yes or no. This is you do the math in runtime code and decide whether the extraction is correct or not.
Exactly. So here you can see exactly what the model did. The model took out this stock form and pulled out a bunch of data about it. And check out what it did here. It said that the price of NVIDIA Corp was 113.063. And look at this price right over here,
Oh no.
right? And you can see why the model did this. It didn't do it for any other number, but it did do it for NVIDIA. And it looks like what ended up happening is the model did this and later realized that that was dumb and chose not to do it ever again. But it didn't. And normally this could be a huge issue if the model did something like this. Imagine you're transacting across millions of entries and millions of stocks. You could easily have this could be a major issue on an accounting balance sheet. But we can do the same math again. We turn that on, and you can see how fast it is because we're not actually using an LLM. We're purely modeling it out. And now we actually are running this out. And now we found that it's off by 27 cents. And that makes sense because 0.003 times 90 is 27 cents. We found the discrepancy. And the idea here is often a technique that we use in machine learning is that one thing might be wrong, but it's statistically very unlikely that you get the wrong quantity, the wrong current price, and the market value adds up correctly. It's very unlikely for that to happen. So we're using a law of probabilities. And then even more unlikely is that all the market values added up together will equal to the total market value up here. So we're just building probabilistic systems, and obviously mistakes can still happen, things can still go wrong, but we're just building a system of unlikelihood. And that's all we can do, just like with humans. It's a probabilistic system, and if you multiply enough probabilities together, they get really, really small. So now that we have this mistake, what can we do about it? Well, the beautiful thing about building a system like this is we have a couple of options. One, what we can do is we can just have a human come in and go update this. Two, we can just record that it's an error. Three, we can go run this over and over again until we get the right answer. Or four, what we can do is we can have another LLM say, hey, NVIDIA Corp was off by 27 cents. Give it just the data for NVIDIA Corp and ask it to extract only NVIDIA Corp. And now the LLM is much more likely to get it correct because you're giving it information about the inconsistency. You don't even have to say what is inconsistent. You can just say when I do quantity times current price equals market value, I get a delta of 27 cents. And now the model can all autocorrect. So now you can go solve this problem. So I'm gonna pause here about numbers. It sounds like people get the point about numbers, and Prashant is asking I think the best question, which is how do we do this for string evals? And I think, does anyone have an idea of what I'm going to go say? regex, close. I think it's more about two aspects of it. One is in the very beginning, you should build a diffing system that allows you to see the diff between the previous run and the most recent run.
Oh
And
yeah, we've done this when we were like migrating APIs for super systematic stuff of like, hey, we're gonna move 100 endpoints to a new system. Like, show me the diff between all the old endpoints and all the new endpoints.
exactly. And a lot of people ask like, damn, does that mean I have to build custom UIs to go do all this stuff? Or like, can I just use something off the shelf? And I've gone through this battle a lot in a lot of different orgs, and we've made totally different decisions. We made different decisions on Face ID. We made different decisions on HoloLens. We made different decisions at D. Shaw. And with all the people that we worked with, I've seen people make different choices. The answer that I have seen, um, the uh, the answer that I have seen all the time is actually that bespoke UIs end up powering your team a lot more than you think. And because of things like V0, it's not that hard to build.
I was gonna say in the last year, the calculus has shifted a lot between should we build something in-house to like kind of just visualize some data real quick versus like, do we need to go get a tool or an open source project and deploy it off the shelf?
Like if I were, every time I build evals for any data set, this is my workflow, whether, no matter what it is. I have a JSON object that I'm rendering. I know the type of that JSON object all the time. And then every single time, actually for every single use case, I actually build a unique bespoke renderer for that JSON object. I'm like diff these two things for me. And like sometimes I want the diff to be exact, sometimes I want it to be approximate. I just like V0 my way through it. It takes about an hour, but if the system I'm working on is really sensitive and I'm looking to like 100 plus input output pairs, it is worth building. If I'm looking at like 10, I just look at it manually and just look at and just like compare the files myself. So the number
Yeah, I
one,
mean,
go ahead.
sorry, no, I mean that kind of tracks in with something I think I've heard, I forget who was saying it, but basically like someone who talked to a ton of founders doing evals for production enterprise stuff was basically like almost nobody is stressed out about building the test harness for evals, whether it's the thing that runs the test, whether it's the thing that evaluates the results, whether it's the thing that visualizes the results. Everybody agrees that the hardest thing is getting the golden data set and getting the actual answer key correct.
Yeah. One thing I wish were better for support works for things beyond React. Yeah, I really wish there was. I mean, we've been looking into how to build different UIs automatically for different data models for you, but it turns out to be a very challenging problem. We're just gonna wait and sit and look a little bit longer before we can, like, I see some patterns more so emerge. But I do
There's
think,
another question here. Why is the LM doing math in the neural network? Shouldn't it be using a math tool call?
oh, this isn't actually doing math for by the way. What this data set is doing is like it's just saying like, hey, I have this data model and this data model, if I can pull the whole sheet up somewhere. This actually has market value, price, quantity, and everything in here, and I'm just like pulling out all the data from like a data I have.
So
And
this blue column is basically not computed by
this
an
is,
LLM.
no,
This
yeah,
blue column is added after the extraction happens by deterministic code.
exactly. It's literally just a React thing that I said where the value of this column is equal to the multiplication of these two things. So I'm not actually doing this in the LM. If you're doing this in the LM, you're wrong. Don't do that. Don't even use the math tool call. Just like multiply the numbers. You don't need an LM to wait for the math. Just do the math. Um, I want to talk about I want to talk about something more specific. So I'm going to pull up an example that I think is going to help make everything more concrete. So for
Yeah,
context, my mother is a teacher, and part of what she does is she makes lesson plans. And you could imagine that we can go to an LLM and ask it to make a lesson plan for us, and that could be good. So let's go take a look at how. I'm just going to write a basic prompt that makes a lesson plan, and I hope the lesson plan example is good enough because it's very textually heavy, and we can talk about how one could make that better. Does that sound good to everyone in terms of like a problem that sounds relevant?
so the inputs and the outputs to that system would be like a couple sentences about the lesson plan, and then the output would be kind of a, two-page structured document of like, hey, here's how to structure it, and here's all the steps, and here's the worksheets and stuff like that.
I don't know. Let's just see what it does.
All right, yeah, let's see what we get. Something like that though,
Yeah.
right? Like the interface is okay.
So it's going to do
Yeah,
something.
you put in a topic and then it generates the lesson plan.
Yeah,
Cool.
it'll do something. And like, I think the first question we all have is how the heck do we measure that? Um, and like, this is probably good enough. So I'm just going to copy this and I'm going to open cursor. And am I sharing cursor?
There's a BAML source in the directory for this
I saw.
episode if you want to use that.
Am I sharing cursor?
Oh, we're still seeing your browser.
Switch. I will share my whole screen, I guess. Okay.
Yeah.
And then let's go to designing evals. And then I'm going to put this and put like lesson plan in here. So now we have a lesson plan. And I think the first thing to think about how to do evals is, remember, ignore the fact that it's generated by an LLM. It doesn't matter. The only thing I really have to eval here is, given some topic, I will produce this lesson plan data model. The fact that a single LM call produces it, the fact that a whole composition of workflows produces it, the fact that I sent it over to some like mechanical Turk that filled it out for me, doesn't matter. All that matters is, given some string, I will produce this data model. So now I know what I'm building. When I write an eval, I actually kind of ignore the fact that this lesson plan works. So like, let's
And this
just,
is that idea of like semi-structured data where you're outputting JSON, but the fields in the JSON are strings, which are hard to evaluate deterministically.
yeah, like right over here, right? Like I don't even know what it did, but it's like, it's outputting something and like, I don't know, maybe this is good. So one of the things that I can do is like time allocation. Instead of this being a string, let's just make this like int and like alias this to time allocation mins. So the first thing I can do is I can change one of my fields to be a number. So now I have a number that's like 45 minutes. Now, what I might want to do when I actually do my lesson plan is, and I think this is the part where people get stuck. Evaluate lesson plan. Oops, client. Okay, cool. Instead of viewing this as a method, all I really need to do here is I need to say, given a topic, string, lesson plan, I'm going to produce some evaluation result for it.
What's
And
the result? Is that going to be a structured object or is that going to be a
so
string or what?
that's the whole point. I could do a string as an evaluation for my lesson plan. And then what I could do as a human is I could go analyze it myself.
You go read the string.
I could read the string. I could really be like, evaluate the lesson plan for third grade students, blah blah blah, and it'll just output something.
And this is basically like a standard. This is like LLM as judge, right? Like
This is
you could,
how
this doesn't even have to be this could be a dynamic thing you do at runtime inside your pipelines if you wanted to, right?
and you just save it somewhere, and every single time our user reports it as bad, you flag that database entry for the lesson plan with its evaluation that you don't show the user
Yeah.
to someone on your team, and they look at it and you go, and now you've kind of built an answer set of some sort of evaluation set on there. Like, this topic with this lesson plan was good. This topic with this lesson plan was bad. And now you've built some sort of proxy for it. And you might even find like the string to be helpful in deciding that. Now, there's another thing we can do. We can actually, so rating systems are bad. Please do not use numbers. Anyone that uses numbers is wrong. So we can actually write an evaluation from this. Now, what makes a good lesson plan? Like, we can say pacing. How good is the pacing? And the pacing can be slow, medium, fast. And maybe I care about how fast the system is. And I just want to know, is the topic too fast? Maybe I want to know like what kind of bias to words, biases, string array, any biases in the lesson plan that I might want to know. Like, maybe there are topics that we shouldn't be covering or examples that we shouldn't be covering, and I want to flag them. They could be examples of any kind. And I can even like add something else here. Any that could be problematic, that could make a student feel uncomfortable. And I could assert that in the lesson plan evaluation, this thing is empty. Like, I always want biases to be empty and very, very validate that. I could talk about like,
Yeah, the one that really stood out to me was like a lot of these need like 6 different materials, like construction paper and glue and scissors and stuff like that. And like you could evaluate like price of materials or something like,
Yeah.
or like scope of material. Yeah.
Estimated costs.
And then so sorry, as we build this, if we run these things, is the idea to kind of build our eval system and then tweak our core prompt and then like see how
Exactly.
our score changes?
Exactly. And it actually becomes really easy to even write this. Now we have like def, lesson, plan, test harness. And like it can be a topic, which is a stir, right? Um, sorry, I can't type very fast. From BAML client import B.
Basically, what we're taking away from this is like there's nothing too fancy going on here. This is all just prompting the LLM in structured ways to get it to talk about what's going on.
Exactly. And now I can build assert. I can build like the pacing is not equal to fast, right? I can assert that biases dot len is 0. I can say the cost is less than like $5. Maybe I'm okay with students spending $5 on a lesson plan or something. And then I can even say like I can even require like I can say like is quality equals input is that good. I can even like print print and at the very end I can even have a last part of my eval set that is just have a human go look at it. So you can see I can build up my systems automatically and like decide where my criteria is. Like, hey, I work in a slightly poorer school district, so I want to make sure that costs are never going to be a problem. In fact, I want all my lessons plans to be free. And I want to build a system that optimizes for free. And it might even be like one of the things in the topics are like constraints, which are a string that I pass in, and that should be passed in to my lesson plan. And this could be a Boolean or something else. This could even be a data model of some kind that produces some string on its own, which is like, what type of school district are you working for? We can eval. If this is something being run live, can we eval against live data? Yes. So the eval against live data is something that I always talk about. So like, this is an example that I use pretty often that many of you will probably have seen by now. Oops, sorry. What is wrong? Sorry, I'm gonna run my, give me 1 second. I'm gonna move this so you don't see my API key. Okay, there we go. Give me 1 second. So like in this case, imagine I'm processing millions of Cambodia visas. And obviously we can do things in evals here. One of the things I can do in evals is literally build the exact JSON that this should pull out. And I'm very sensitive to certain things. Like I want to make sure that it correctly checks these checkboxes off. Maybe I don't care if I want to make sure that it gets the personal information perfectly correct. I may not care perfectly about the address or everything else because I can use corroborating information to find that information.
Yeah. Sorry, real quick, yeah, and maybe to guide this a little bit, I'm really curious to know, like, let's say you've processed 100 of these visa forms and you've pulled out the schema and you have your golden data set. Like, how can you make a statement about, like, I am now confident that we are 98% accurate at extracting data from forms like this? Like, how can you kind of take the past results and be able to say, reliably, like we expect our future performance to be 98% or 91% or whatever it is.
Yeah, that's usually where people struggle. And the answer is you can't actually make that statement perfectly. You're missing a step in order to make that statement. You make the golden data set once, and now you're like, our pipeline works on a golden data set at this percentage of accuracy and meets our criteria to ship. So,
Right. How do you know if you've overfit to that data set though, right?
so what you do then is you actually have to spot check your production data at some cadence and continue adding to your golden data set at some cadence.
That I
That's
know I interrupted you in the middle of talking about this thing, but it could be useful after to pull in and like what does the architecture of that pipeline look like? Like where in the process are you storing stuff and like how do you build that?
So, I mean, this is just one way to do it, but you don't actually have to, just to be very clear. What you really need to capture when you go down this road is, did I capture everything? Oh yeah, let me change this. What you really want to do when you go down this road, how do I change this? 30
You're talking about just like capture every input output pair.
You literally have to capture every input output pair, and there's no shortcut around this at all. And more specifically, what you really want to go do is, give it a second, is when this data comes back in or out, what you really want to say is like, how well is my is blog post function doing? And you just have to spot check and look at is blog post, and there's no good shortcut for this. You have to build up your eval set continuously over time. And you have to say like, for this HTML page, is this actually the right title on the blog post? And like, you can imagine a title for a blog post is like, I don't freaking know. Like maybe, is this the right title? Is this a blog post? Is this not a blog post? And for context, just to show everyone what this was running on, is I made a small little demo that I wanted to go do, which was when I go extract data from like, let's say I have a bunch of blogs. I want to go see for every single blog on an entire site, what is it, what's the value ratio? Is it balanced? Is it an ad or is it educational content? How deep of educational content is it? And then what insights does it have? So it's probably very easy for me to like actually build a golden data set around primary intent. That is really easy. Key insights is going to be much harder for me to go do. But what I can say is Next.js should be mentioned in key insights somewhere. So I can just regex for that for this specific blog post. Not for everything, but for this one. And that'll take me time. The other thing I can do is I can rerun this same exact data model on my next prompt and just see what it output out next time. And just look at the diff between these two structures. Yes, exactly. Yes, for now, Prashant, you're totally right. Like and it's not even living in your code. I think that's the most important part. It's not even living in your code. It's living in a hybrid of your code and your data. And that is the part that most people miss. Evals are not purely living in your code because evals are purely a diffing mechanism. You have to build a
Sorry, Vaibhav, what does living in your data mean?
So like in order for me to actually eval this correctly, what I need to be able to do is I have run this like 2 weeks ago. Last time I was building this prompt. Then a new engineer comes on, and let's assume the models have stayed constant the whole time. Nothing has changed about the model in some way. And a new engineer has come and started updating this prompt in some way. What they really want to know is the last time I ran this, I got this output. The next time I ran this, I got this output.
And so that's like on your PR, you could get a like output from some eval system that basically says like, cool, here's a link to a page about how all the outputs have changed between the first one and the second one. And someone can literally go skim those and eyeball those and say like, oh, that's a huge block of red. Let's go see if I broke some edge case that we know we want to make sure still works.
Exactly. And you can even build like a rule set around that. It's like, hey, my diff for my eval should be small. So you can measure the lines of diff in your eval. So like even though it's a text thing, you can build a diffing score of how big of a diff you have. And the fact of the matter is, because these are probabilistic systems, you really have to go look at this. What is that question that someone had? I can imagine seeing a huge wave of error messages being mentioned by the LLM being a good flag for people having issues. I don't understand that question, John. If you could articulate, that'd be helpful. And I think Jonathan nailed it. It's very similar to screenshot UIs. Like there's like front end. Whenever you work on front end code for the first time, you're like, why does no one write unit tests? And you write unit tests, and you quickly realize if I write unit tests, it slows down my shipping by like a bajillion orders of magnitude. And eval systems are really similar because the way you would write a unit test is not useful for most of it. In this case, I don't need to say, I have no desire to say exactly what the key insight is. There's so many different ways to say these same topics. It's totally useless. But I do want to say one of the key insights should include the words React and Next.js. So like I can go build a stronger eval over time. And what I really need to make sure is no matter what happens, no matter what the prompt is, it always answers React and Next.js in all scenarios. And I have a good system. My primary intents can be hard-coded. For now, yes. So is everyone making their own internal full stack eval applications? I wouldn't really say they're full stack eval applications. I would just view it as like when you write like code, when you write code like this, like you don't expect anyone else to write your React components for you. Your React components are very special to your own websites. Your functions are very special to your own system. You might use really core infrastructure, but you typically will use systems, and things you don't care about, you will offload. Like we don't all care about that chat widget that pops up on our website, and we're okay offloading that to someone else because we, as a social paradigm, have built that sort of paradigm out there. So even some evals, like, hey, maybe someone has built a really good sentiment analysis evals for like e-commerce chatbots. That's okay. We can leverage that. Just like we could use that little chat UI widget. But we probably won't build our entire website off of widgets that we don't own. And that's really what we recommend, which is learn how to write the evals yourself a little bit. And then as you write the evals, it becomes really, really easy to kind of build small little test harnesses like this one. And then you just run that on a bunch of data sets and you dump out files and you build small visualizers to go do this. And I would never, like Dexter was saying, like this is a game that has changed now. Before you would have to compromise on worse dashboards, worse systems. But now if you're an engineer working on a part of a pipeline, just build it. And it's like you can build a Next.js object that renders a type that is well defined because you have a type here that you can just render. You want to render a lesson plan object, go do that. You want to build like you want to render this right now. You can go do
We got 7 minutes. You wanted to show us how you vibe code a eval visualizer?
Yeah.
Like let's make 10 test cases on third grade math topics and like let's vibe eval.
Let's do it. Let me go run this really fast in that case.
Yeah, we got 7 minutes, but I think as usual, we'll probably go over. Let me just ping and see if we have any other questions. Yeah, so is everyone making their own internal full stack eval applications? Sounds like maybe some people.
You probably should. Maybe I'll go.
And Andy had a good question. Is like, is it the same model call that is generating the eval or a second agent? And I get this question a lot as well. While you're doing that, I'll just kind of like think through this out loud, and then I want to get your answer, which is basically that idea of like if you ask one model to do a thing and then you ask another model to evaluate the thing, maybe you get some value from cross-pollination. I see this a lot in like consensus pipelines as well, where you say like, okay, here's the question. Let me fork it off to 4 of the best models, and then let me have a 5th model basically review all the answers of those 4 models and then decide which one is better, right? I think DSPy calls this like a consensus or a judge plan or something like this. And the question I always have is like, well, if the model couldn't get it right the first time, is the same model going to be able to get it right the second time? And or like if the second model is smarter than the first model, why don't you just ask the second model like in the first place? And I think there is a little bit to be said for, I think there's a couple papers on like if you ask Llama 70B the same question 50 times, you get almost as good performance as Llama 405B or something. Like there is value into doing these things over and over again and then like synthesizing the results. Let's see.
I think that
I'm reading.
like should use the same model for everything. Like, no, just like your agent should not be the same model everywhere. Like instead of viewing this whole thing as like a separate people, I think it's the same mistake that people do when they build like entire AI pipelines. They're like, my agent is one thing, but your agent is decomposed of many, many boxes. In my chat agent, the thing that builds the intent analysis could be a really, really simple GPT-4o mini model, maybe even a Llama 8B, who knows? But the thing that generates a SQL query, maybe that can be a 70B model. And the thing that does a Cypher query against my entire like data warehouse, we're going to use O3. The fact that I'm using different models for them is more of a necessity for how ambiguous and hard the problem is. And now what you can do over here instead is you can just do the same thing here. Our eval system could use a different model here. Like in this case, I'm using the same one. I don't think it really matters, but I will switch to OpenAI really fast. Actually, I don't care. Let's use Sonnet. It doesn't really matter. And we'll go run this. And now I've built this in. So the first thing I'm going to go do, and this is what ends up being really hard about eval systems, is a lot of times people assume that eval systems are easy, but they end up being really hard because I do not want, like if one of these asserts fails, I get no information about the other asserts. And that's actually where things end up being really hard to go read and write. And also, if I forget to save the data before I actually run this, that's another thing that ends up being hard. So selfishly, I was actually hoping to show this off later in about like 3 weeks because we had a new thing that was going to make this way, way better. But I'll go write the
Let's
code.
see it.
Um, test one. So now we have two tests that we're going to run, and then we'll just run like, I think like PyTest. Import PyTest.
You probably have to UV add it. Yep. Nice.
It's probably this. I have no idea. UV add PyTest. And then 1 second, I gotta put my API key. Am I still sharing the window? I'm not, right?
We don't see the terminal, we just see the cursor. And yeah, John, that's a great comment. Evals are a great use case for switching out agents models on which model delivers the best value for cost.
Exactly.
Yeah. And that comes back to a thing we come to all the time, which is like make it work. I mean, in design and like product engineering, we call it like make it run, make it right, make it fast. And like in LLM world, it's like fast and cheap, I guess. But it's like, yeah, get the thing working. And then if you have a good eval set, you can say, cool, we're going to try to rebuild this pipeline with 4.0 mini and just make the prompt really good instead of using O3. And you'll know exactly how much better O3 was than 4.0 mini. And you'll know exactly how you're doing at changing your prompts to make O3, O4 mini, 4.0 mini almost as good as O3.
Why is this failing? Well, we'll find out. I forgot to run dash S. Let me run that again.
Also, I think you're having like async IO thing. I don't know. Let's see.
No, I'm not. I'm not running async. I probably should.
Okay.
And now I'm running. So the first thing I'm doing, I'm really just gonna run this because I just wrote some test cases. I'm gonna go run it, test index 0, test index 1, and then it's gonna, and you can actually see what it did. It pulled out the lesson plan.
Something just can.
And then it's gonna take the lesson plan and pull this out and said pacing was medium, biases, physical activity like hopscotch might be challenging. That's true. Like maybe physical activities are actually bad. Group dance activities and then competition is bad. And then now there's another one that says a pizza activity. And what does this do? And this failed because I forgot to make a directory. New folder, evals. Okay. And then what I'll do is run state equals. And you can see what the most annoying parts about this is, which is why I wanted to show the cleaner code, but that's okay. There we go. Okay.
That looks pretty good.
Well, no, just like what I mean is like, you can see how there's so much work that I have to do just to get the data out of the system. Like when I'm building an LLM pipeline, this is actually one of the most annoying parts. So like what I'm really excited about is being able to run BAML CLI tests and automatically be able to have the diffing and everything done for you automatically and just have JSON stuff saved.
Oh, like is it going to dump out all the input output pairs to like some temporary storage space or something?
Yeah, exactly. Like BAML CLI test and like be able to even better, just do something like this dash dash prod, dash dash like compare equals prod tilde 2, and you can just get the last two entries in prod and compare against them.
Oh, sick. That's like the Git syntax or whatever.
Yeah, just
I
use
love
like
that.
Git syntax to kind of invent that for us. And I have to make a new directory.
Just my 2 cents, I use BAML CLI test a lot and it's really, really good. Gives me feedback very rapidly, but then you can't do the diff right now. So I end up writing manual Python code to do the diffs.
Yep, that's kind of why. And you can kind of see what I'm doing with the diff here. And really what I do with the diff is once I have this generated, this will generate in a couple seconds. And I'll write everything down. And the other benefit once you do that is you can get caching and everything for free. So you can like modify your eval prompt without having to modify this prompt, which is kind of nice. But like, we can just see what's happening. And like this looks pretty good. So now what I would do is, now this is good and this actually failed. That's fine. I don't really care because I saved all the data. And now what I would do is for every run, I just build a UI that actually does this for me. So let me make an npm folder. No, ts proj. CD tier.
If we have time, I have a funky example cooking over here as well that we can look at.
Okay.
But this is structurally super interesting and helpful.
Wait, why did this run? Oh, I'm dumb. There's another thing that happens when you do this. You realize that you saved data into the wrong folder. I need one date folder for my entire run, not multiple.
Oh, yeah, you got to make it one time. Okay.
Okay, cool. And this is what I end up doing now. So I'll show you guys my exact workflow. I go here, I say, I will run some tests each time. And all my tests will be in that folder structure for each run. Run underscore date slash at data underscore test idx dot JSON. Oh, fuck. I hate this. Stop. Okay, sorry. Maybe I'll cut that out. And then
And
what
then you want to
I do,
actually paste in the data format, right?
here's an example of, actually what I really like to do more than that is actually what I'll often do, and this I find works even better.
Yeah.
Example of the type I'm saving in the JSON.
Look, it wouldn't be an episode of AI that works if Bob didn't sneak in a BAML is more token efficient than JSON quip.
I haven't said that yet.
You implied it.
Let's see.
Well, I guess this is putting in the types rather than the data themselves, which is probably much more interesting for building UIs.
Exactly. Because like that, the model, if I give it this shape, it won't actually know. But if I give it
Yeah.
the lesson plan string, and then what's the next one? Evaluation. And the thing is, like, I just paste the stuff in there, and it kind of just it'll figure something out. It doesn't really matter.
Is lesson plan a string? I thought it was
Yes, thank
the
you.
lesson plan type.
This is why it's great to have someone else there. I want to render a diff of, oh shoot, I forgot to say one more thing. Dang it. And while this runs, I'll rerun this. I want to render a diff of diff
The
for
evaluations per topic.
over multiple runs to show the diff between lesson plans. Then also show the lesson plans and their evaluations. Cool. I'll let this run. While I do this, I'm going to fix my sin that I wrote over here, which is I forgot to dump out the topic. And this is what I mean by it's very easy when you go write these systems out to actually like accidentally do something that you didn't mean to and like just forget to go do something. And like imagine you spent like $5,000 running this and you just forgot to record the topic. You're basically doomed. You just have there's no shortcut. And this is why I think this is so hard to do because it's not like even me going into this, I know I need to save the topic and I forgot until the very end. So like, where did it go? Yes. I will run this again. And now it'll go do something for me. And it'll probably be somewhat reasonable when it does this. And now the good part, by the way, is like if you want, you can just code gen all these types in TypeScript pretty easily for BAML too. So let's just go do that. Why not? I will do that as soon as it's done. Nice. Now we have this. Okay. And then this will go do some stuff for me. The problem is you end up waiting, but this is way better than trying to figure out some other system that isn't going to be perfect because I can get this to be very correct. Can use eval history to backfill topic. You can, but then you're basically just data cleaning and data cleaning sucks. It's honestly just faster to rerun it.
Yes.
But now you can actually see what it did. It's kind of cool. It actually built the system out for me. It lets me compare and just lets me pull that out. And it'll actually show me the diff. And you can see how fast I did this. Right? It's not that hard at all. I just use cursor. It doesn't really matter. The reason I use V0 is because I don't have to spin up a whole node project, and I can just see if it's actually what I want up front. And once it is, then I download it, then I move over onto cursor. If that makes sense, Prashant. So, but like you can see how fast this is. Like great, and I can actually see the difference. It's like cool, and it's actually showing me what I have. And like now I have an eval suite. This is sick. And I'm like, oh, now give me a click through button up here so I can just click and just compare, and I'm done. And then also load this from disk. And now I built an eval system in under 5 minutes. I can iterate on my lesson plan really, really fast. This is how I think people should build evals. And if you're not doing this, you're hurting yourself and your company and your likelihood of success of building a successful pipeline. It's like the whole goal is go from like,
So yeah, I would say like let's like can we put together a checklist in like the README here or something of just like what's the steps, what should I do first, and like what are all my boxes to check to know that I'm kind of like on the right path to make this happen.
yeah, that's a great thing. So I think step
Like
number one that everyone should be doing, vibe evals. That's it. Just
so
vibe
what is
evals.
that? So what does that mean to you?
To me, what that means is you're going in the playground and just hitting play constantly, and you're actually looking at the data. That's part one.
Okay.
Step number two, as soon as you've got your vibe evals down, like that means you're actually reading your prompts, you're writing test cases, and you're actually hitting play. And just think about what test cases actually make sense. And even the act of thinking about test cases is going to help you be better at your system because you're going to think about where people can fail. I remember when the minute I started talking about evals, people were like, oh, I forgot the messages on here, but in the thread, people were directly saying that there's so many different ways to measure the lesson plan. And they're like, you could think about a few, I don't have the section. People instantly had ways to judge the plan. Do that for your own prompts. Like just write a few. Two, capture the intermediate steps of your entire pipeline and try and eval the steps that are most easy to eval. Don't try and eval
This
the whole pipeline.
Yeah, this comes back to like the testing pyramid, right? Of like you should have small super granular tests and then you should also have what is it? Testing pyramid.
Man,
Oh
I feel
man.
like Dexter, you
This
know
is gonna
all
be
the
some
actual formal terminology for all this
yeah.
stuff. Exactly. Yeah, exactly.
This is this thing of like you should have little incremental tests at the smallest possible granularity because these are faster, they're more isolated, and you can iterate quicker. And then you should have end to end. I mean, in the AI case, it's not UI tests, it's like end to end full pipeline tests.
Yeah,
But it's idea like a lot of your tests should be these smaller, more granular units.
yeah. Because if you know that the intent capturing is correct, we can worry about the next steps, not the first steps. If you know your messages have the right tone because you look at them and you vibe eval them, you can worry about the intent analysis being correct. Exactly. Engineering is engineering. There's no shortcut here. So those are like two big ones. Things that I recommend focusing energy on as a team is I always recommend people build structured outputs whenever possible and like break your problems down. Like Dexter says this all the time, and it's one of his things. Like think of all LM things as tools or really just classes that you're returning. Like once you're able to do that, it becomes really, really easy to write evals for certain parts of your pipeline. And then really it's more about don't use numbers for confidence scores. And the reason you don't use numbers is because like when I got an English paper, I remember this all the time. I don't understand why I got a 92 instead of a 97 half the time. It felt like it was
Whoa.
discretion. Well, okay, that's
I didn't
okay.
realize this was the are we bragging about our English paper scores
Okay,
now?
fine. Let me be more honest. I was more at 82 instead of a 97. I was
Listen, you
not
don't
very
have to
good.
lie. We love you for who you are.
Yes, that's right. But in reality, I never understood what those numbers meant because they felt very arbitrary. And most people, when they give a numerical system, don't have a system. They have like a completely arbitrary system. So it's like you notice that when I actually wrote the eval system, when I was writing it, I just asked it. And like the model came up with a good idea for what an eval system is for that. But categorical systems are generally way better than numerical systems because no one knows the difference between score 7 and 8. So don't put a category in there that has no meaning.
Do you put like enums in that as well? Of like yeah, outputting like a string that represents like a category. Yeah, when you had like slow versus medium versus fast, right?
Exactly. Exactly. And like Jonathan said it right. It's like it's the same with stars on Yelp. Like I don't go to a restaurant that has less than 4.8 because that means they suck. Like if they don't have a 4.8, they're just really bad. Um, and it's more about thinking about categories better. And you can add descriptions to categories to say exactly what they mean and just break your problem down to a classification problem. You can think,
On the probe question real quick that just came up, I think the idea here would be like in your we'll share this in the whiteboard, but basically like you have your full pipeline where you pull out an intent and then you list the products for that intent and then you build your answer and you return the answer and you also return things about the intermediate steps so that in your test you get the output and the probe. And we're actually not going to make assertions about the answer because it's like a chatbot generated big string. Maybe you can, but the idea is like let's make assertions about so that when this test fails for some reason, maybe we are also evaluating the answer, we immediately have assertions about each intermediate step as well that we can say like, oh, the intent was wrong, and so everything was screwed up.
and the alternative here is this concept is, I think the concept that people are most familiar with that looks like this is mocking. So instead of actually doing it, it's like you could technically mock what get intents does, and then you kind of have you can kind of eval just the next part of your system, if that makes sense.
Right. You test your get intents function and then you can mock it in your pipeline. And you say, hey, as long as we get the intents right and we get the products right, then we are just now testing the final chat output.
And
So
now,
that's an alternative to probes, right?
they're kind of similar. Can you go back to your system, the diagram that you had really fast, just to articulate this
Yeah.
a bit better? So like here, you can imagine that I wrote it. So probes are one way to do it. It's the easiest way for most people to do it. For people that are more comfortable with mocking, what I would recommend is in chatbot, you could just mock the get products function and the chat response function to return a fixed thing. Well, you don't have to pass it in. You can just use a mocking library.
Sure.
And then you could just mock what get products and chat response does. Like yeah, there's exactly. You get the point. And now what you can say is now you can basically assert what intent should be in your mocked functions. So there's multiple ways to go write this code out. Yeah, exactly. Exactly. Oh, I can't believe you actually know this off the top of your head. This is why you're a much better engineer than me.
I don't know about that.
I do not know this stuff. I just know.
Yeah.
So, and then you can, exactly.
And so then you don't really care about this probe stuff anymore. And you're just going to like break down the problem and solve it at each level of the pyramid, basically.
Exactly. So now
If
you're,
you have ever seen this talk, we'll put in the show notes. I think it's JD Rainsberger. Integrated test scam. This is an incredible talk. Yeah, integrated tests are a scam. It's an hour and 5 minutes on why only testing things end to end is going to destroy your team and your product and your company.
yeah,
And the value of like following this pyramid and focusing on small pieces and the contracts between parts of the system.
yeah. And then can you go back? And then,
Yeah.
sorry, not to here, to the dashboard, to the notes that you're writing.
Yep.
And really this is a checklist. And I think the most important part is,
Yeah. What else is missing from this?
oh, sorry, one last thing. Use prod data to build up your golden data set continuously over time. Do not stop. Specifically, you should write only integration. Only using integration tests is a scam.
Sorry. Yeah.
Yes. Integration tests are fantastic, and you should have integration tests. But if you only have integration tests, you are being scammed.
Yeah. Well, it's like if you're using an integration test to catch a thing that broke between these two small components of the system, it's quickly going to explode into 700 integration tests that are very slow to run and very slow to run one of them, let alone run all of them. And when one of them breaks, it's going to be very unclear which part of the pipeline broke.
Exactly. And I'm gonna pause here because I think hopefully what I can do is I can send over like some actual like tooling scripts that we have that have been useful, but we'll share some of them pretty soon. But really you want things that can pull data. What you really need is you need something that can pull data from prod, You need to build tooling to visualize the differences between different outputs. And you just need to make that really easy so that every engineer wants to go do that all the time. And I think the best analogy I have at this is like back at the hedge fund that I was working at, they had like around, I think, their unit test used to take like 30 something hours to go run. So obviously none of the engineers ever ran the unit test, or they'd run like the one file that they know. But we all know that changing one file, running one file of unit test is often not good enough. So like what we found was we built a system that could say, given a Git diff, we wanted to predict exactly all the unit tests that would need to be run. And we actually built that system. And we found that on average, for 90% of commits, people had about 5 minutes of tests to run. And that changed how people worked because they always ran all the tests. Like, because and what we did was we made a single command. It was called delta test. You would just run delta test and look at your diff and be like, this is what you need to run. And we'll just run it for you. And that was actually even easier for people to run than actually determining, than actually like even thinking about the file that they run, because it's even one less work item. And I think people need something like that for AI systems. Like if someone is working on a prompt, they don't have to think about running unit tests for that prompt. They want to run something like delta test and basically say, run the entire pipeline that depends on that test and never think about it again. And I think that is going to be the answer. Steve, you had a question.
So now that you've teased everyone with this magic system, how was that? How were what training was used to then predict, what tests to run? Like, what did that look like at a high level?
I wrote an algorithm. There was really an algorithm that I wrote.
So were you like parsing the AST of the entire code base and then doing analyzing the graph basically?
Yes, but the only problem is in Python, you can modify global variables and changes the AST quite in nasty ways. And then you have C Python code that you have to deal with, and then network dependencies and data dependencies. So I wrote an algorithm to deal with that. It was fun. It was very fun. A lot of state testing. So I think we'll probably end up building something like that for LLMs, because I think people want something like that as well.
We got a good question from Adisha here. Struggling a bit to understand the value of the diffing UI.
Okay, let me tell you why you want the diffing UI.
Can we like whiteboard out like the workflow steps or something like that? Yeah.
What screen am I sharing?
This is cursor.
Cursor. You see cursor. What do you see now?
I saw trees for a sec, and now I see cursor. Oh yeah, now I see it.
Okay. Why is this better? Well, Adisha, the most important part here that you have to kind of get around is that when you go do this, this is just easier to go read than looking at JSON dumps. And when you're looking at hundreds of them, you need to go do this. And it's not actually, it's not embarrassing at all. It's really, really intuitive. It makes sense. Like, hey, we're programmers, we're engineers, we run all this stuff programmatically. Why are we suddenly building UIs for this? And I think the best analogy is data science. We all have recognized Jupyter Notebook is incredibly powerful for data scientists and for machine learning people. And the reason Jupyter Notebook is really powerful because it combines visuals with code. And that's what you need to do when you're in this world. You need to look at visuals plus code to get really fast feedback. And really, this isn't even good enough. It's like, I want an arrow I can click to quickly skim test indexes. Like, I really want an arrow that I can click. I'll just like do it for me so I can just like make it really, really fast. And I think once you get in the habit of thinking of it this way, like I used to get so annoyed every time I had to spin up a Jupyter notebook because I was like, oh, I have to install IPyKernel and I have to like remember what it is. But once you get in the habit of it, it's like there's no better way to build plots and analyze data because I'm manipulating things all the time. And I think normally I would say stick to Python if that's what you're most comfortable in. But the problem is we're no longer looking at graphs and analytics. We're looking at things that are a lot less graphical.
They don't just like plug into standard components like an XY axis or a pandas table.
Exactly. And that's not what we're doing. So it's like, okay, now I have to just like, and now I just want to like rotate here and just like go do this. And it's like, I don't know why it's taking forever to load. It's so slow. I'm like, okay. And I'm literally just going to tell like, instead of load everything at once, then show it. So it doesn't lag when I press next. And like it'll just figure things out. And I don't actually spend a lot of time while I'm doing this because what I often do is like I'm iterating on this thing while it's running, and then while I'm on there, I'm actually like just running stuff in the playground, looking at things manually to build a
You're
better.
changing your prompt, and then you're looking at how the diff changed, and then you're changing your prompt, you're changing the order of functions. I mean, this is all about, again, that quick, like, iteration loop. At the end of the day, like, yes, this is useful as an artifact to like before PR goes in, like eyeball and make sure it's not going to break anything too impactful. But it's like, cool, I'm trying to make this thing more accurate, or I'm going to try to like I'm trying to get it. It's 99%, but it always fucks up this weird edge case. Can I change the prompt or change the pipeline or change the format to get this weird edge case? And this becomes the thing that you can do to be like, cool, I solved my problem. Oh, but I broke 7 other things, and it's very visually like I clicked 3 times and I can see that it's broken. So we have to go back to the drawing board.
Exactly. And it's just going to be faster to iterate. It's really annoying. I know for a lot of people this feels annoying, but like I honestly I have nothing but to say. And you're gonna see how like nice this is. I can just like look at this and like cool. And I can just like manually see like what's happening between the two, and I can like cool, this is the difference.
Yeah, and you can show this to a non-technical person, and you can say like, "Hey, here's how we're improving this week versus last week."
Exactly. And this is really, it just makes life way faster. And by the way, don't do this the minute you start writing your prompts. Do not do this. The answer is look at it, vibe eval it. Honestly, I ship things with vibe evals, and that's okay. I see many people do that because what we want to do
Yeah.
is vibe eval that's good enough, ship it to prod, collect prod data, use prod data to build golden data sets, and then build diffing and all this other tooling after that.
We had a really mediocre prompt live in our production systems for about 12 weeks. And then one day a customer wrote in and was like, "Hey, it did this one thing weird." And we went and we found the exact data from the weird thing it did. We added that to our test case suite and said we need to handle this as well. And we grabbed a couple other weird test cases while we were in there. Like some of this stuff doesn't look right. And the issue was we had this thing where like a smaller model, like a 4.0 mini, was kind of just like regurgitating data from its training set. I don't know if y'all have ever seen that thing. It was like, okay, cool. Like let's add a couple tests for these weird things and let's change the prompt. And we actually ended up changing the model, which broke a bunch of our existing tests. So we had to change because 4.0 is a lot more it's a lot smarter, but it's also a lot smarter. And so some of the things that we were relying on GPT 4.0 mini to do cleanly because it's too dumb to actually think about the problem, we had to go like change the prompt to be like, don't try to be smart about this. Don't try to answer the question. Just pull the text out. But anyway, that's like a real workflow that we had in production where it's like we shipped a prompt that was like pretty good. I vibed it on a couple things and then I waited for it to break and then we iterated as we go. I mean, putting things that you know are going to break is bad, but also like spending 6 months on evals before you ship a product to somebody and like find out if they even want it is really dangerous.
Yes, it's way worse. And think of it like that fake buy now button that we used to have on websites, but they literally just do that to see if you clicked on it. And if you clicked on it, they'd be like, shit, we should sell that thing. And then they'd go sell it.
Yeah.
And now you're
Call
just
it the fake door test. You'd be like,
Yeah.
if people try to open the door, then you know they want to go in there, and then you go, build out whatever's supposed to be behind it.
Yeah. If people are complaining about your system, then you have real data that you can work with to make it better.
All right, let's do one or two more questions, and then we should probably wrap up.
Yes, we're 25 minutes over. Two last questions, and we will call it quits for today. And if there are no more questions, we can call it quits and go back to work. What's a good mental model to when to split a prompt into intermediate steps? I don't think there's generally a great model because it really depends on the capacity of the model that you're using. If you're using an AP model, it's probably earlier rather than later. If you're using a stronger model, but your steps are very, very intertwined, it might be earlier rather than later because you might want to have value in discretely defining those steps. It's really about how well you can define the problem and honestly, just like press play and keep on testing it until you get to a good point. Like you have to build that intuition yourself based on your domain.
Yep. All right, one more question. Would it make sense to self-introspect on outputs during runtime and correct them if the LMs take no time to output and evals are fast?
Yeah.
That's basically what we did, the deterministic runtime evals that we did of adding stuff table-wise and row-wise. Does it make sense to also do kind of introspective LLM-based evals at runtime if they're fast?
I mean, whether you're using an LLM or like math to do that calculation doesn't really matter. It's up to you, and you can definitely do that. And we have people. The financial thing I've shown is I've seen multiple people take variations of that approach to build like document validation for all sorts of things. And like we have people running pipelines with 99% plus accuracy on like 100-page plus PDFs on data extraction. It works. Because what ends up happening is when things go wrong, they literally ask an LLM to go fix the thing that went wrong. And because of how LLMs work, because they're now focusing on just one part of it, they're able to go get the right answer more often than not afterwards. So if you get feedback from an LLM, like a really tiny one, maybe a 1D model or something that you're running on an edge device, you can use that to build corrective behavior as long as the thing that you're measuring on is actually good. And I was showing this, for example, like right over here. Like you can imagine for this visa form, I could build the same system. I'll find everyone that was flagged as first trip to Cambodia true in my data set. And if they're flagged as true first trip to Cambodia, I'll make sure a human looks at it. If it's false, what I'll do is I'll literally look up their passport number or whatever I have in here. I'll look up their passport number in my database and see how much of the information validates. If everything matches and it's all the same, but the address is different, I'll kick it off to a human and have them only compare the address and say like, is this the right, is this a good up-to-date address? Should we update this? Or maybe even email the person and be like, are you sure you want to validate your address at this way? And I've kind of built this automated system.
That's an incredible note to close on. To summarize all of this is building evals is not that hard and it's not that much code. Um, I think there's a lot of like eval systems off the shelf that you can buy that force you into a very structured way of thinking about this problem. But at the end of the day, none of them will let you build the pipeline that Vaibhav just described. And as you scale, it might make sense to grab a solution off the shelf. But at the start, you should understand what you're testing, how you're testing it, and like keep the flexibility to build this however you want so that you can have a really flexible pipeline architecture and you can evolve your testing systems with it.
Dexter nailed it. I will add the links to the V0 and we'll push the code up so you can just see what that ends up looking like as a whole.
Real quick announcement. Thank you, Andrew. We are doing a workshop. If you're in San Francisco, we'll post the link. But we are going to do a all-day workshop mini conference in SF. So if you're in town, come hang out. It's going to be a good time. We just did it in New York last weekend. People loved it. So should be great.
And then we'll see you guys next week.
All right, folks.
New topic
Thanks,
right
y'all.
now. Bye, everyone.
See ya.
Bye.